This is section 7.2, linear programming and graphical methods. So this section may take you a little while. You may want to do write the notes down and then go do one problem at a time. It's up to you. All right, so we need to use graphical methods to solve the following linear programming problem. Okay, so we need to minimize z equals 2x plus y, and it's subject to the following constraints. Okay, so we do need to graph these. If you ignore the inequality signs, we do need to graph these. So let's look. All right, so these two down here, let's look at those. So that is just going to be, we want to graph x equals 0 and y equals 0. So let's go down here. And those are just straight lines. That's just the x-axis and the y-axis. I'm going to do this in a more prominent color. So x equals 0 is just the y-axis. And then y equals 0 is just the x-axis. Those are pretty straightforward. Now we need to look at the two before those, x plus y. We're just going to set these up as equations just for graphing purposes. All right, so let's solve for y. And I want to do this on both of these equations. Move the 4x. Divide out by 3. Let's assume that you know how to solve for y on these. So minus 4/3 x. And the order, whether the x term comes before the one without a letter on it for the constant, before or after, it's irrelevant. All right. So let's look at these two. Let's find the x-intercept and the y-intercept. So the first thing we're going to do is we're going to let x equals 0. Okay, let me move that down just a little bit. Some of this little scratch work. And then I'm going to let y equal 0. So if I plug 0 in here, that goes away and I get y is equal to 9. So when I plug in a 0 for x, y is equal to 9. And then and it doesn't matter which equation we use, if I plug in a 0 here for y, it goes to 0, x is equal to 9. Okay, so that line has to be graphed. To graph a line, you need 2 points, and you're just going to use the little line tool. All right. So this will be the third line that we're graphing. Because we graphed on the x-axis and the y-axis. Let's look at this equation here. Plugging a number may not be as easy. Oops, sorry about that. All right, so let's also find where these cross the x-intercept and the y-intercept. So for x, we're going to plug in 0. So if I plug 0 in here, 4/3 times 0 just goes to 0, and y is 4. All right, now let's plug in 0 for y. So we can do that up here. Did not mean to erase that. Put that back. So let's go back to the red. All right, so if I plug 0 in for y, that goes to 0. I end up with 4x equals 12. Divide out the 4, so x is equal to 3. So when I plug a 0 in for y, I get a 3 for x. So we're going to graph that. This will be the fourth line you're going to graph in here. So if we look at this, we have 4 corner points. I'm going to highlight those. We have one right here, right here, right here, and right here. Okay. So those are our corner points, which would be the 4 points right here. These are the corner points. All right, so we are going to have to shade in here. It says x is greater than 0. So that is, I want to show you where the overlap is. Let me get rid of the shading real quick. Right. I don't know why I won't erase. All right. I'm just going to use the draw tool. Let me get a lighter color. All right. So x is greater than 0 and y is greater than 0. So that means everything in here. That's x is greater than 0 and y is greater than 0. Those are the two easier ones. The other two we had was x plus y is less than 9. Okay. We did convert it to an equal sign. So let's take it back to the original sign it had. Let's go back to blue. X plus y. All right, so y is less than, so let's see where that is. All right, so that less than would be on this side. And let's look at the one on the right. This one over here, we never divide by a 0. So the inequality sign is going to stay like it is. So, and that inequality sign was greater than or equal to 12. So that was the one on kind of the bottom left here. So if we shade, greater than or equal to would be up here. So the area that you're going to shade in my math lab is going to be where all 4 of those overlap, which will be right here. That's the area that's going to be shaded. All right, now we need to finish this up. We need to minimize the equation that they gave us. I'm just copying this down from above. That's a Z. All right, so we need to minimize this. So we plug in each of the 4 corner points and see which one gives us the smallest Z value, okay? Plug in the second one. All right, so I took each of the corner points, plug it into the X and Y's. So the smallest we want to minimize, the smallest value is right here. So for the answer, we'll say the minimum value of z, and this will just be a fill in the blank. Minimum value of z is 4 at the corner point, and that was when we plugged in 0, 4. Right here. These are long problems for this section, so we've got 3 more to go. Let's go down. Again, you can always pause this if you need to, like maybe work the problem and then come back and work on the next one. All right, so this one's similar, but we're going to maximize instead of minimize. Again, we also have x is greater than 0, y is greater than 0. Basically, that's just restricting us. Everything's going to be in this quadrant. We do need to draw those lines again. So x equals 0 is just your y-axis. And then y is equal to 0 or greater than 0 is your x-axis. Those two pretty straightforward. All right, so let's look at the other two. I think I'll just leave the inequality in there. Just right. All right, so let's solve. We don't really need to solve. Yeah, we do. All right, let's subtract x. You could put 8 minus x or negative x plus 8. Now with this one, to get the y by itself, we do have to divide out a negative. So divide everything by -1. It changes the signs. And it flips the inequality. So be careful with that. Only if we multiply or divide by a negative is it going to flip the inequality. All right, let's do this one. Let's move the 2x. Divide each one by 7, which is positive, so that inequality symbol stays like it is. Oops, 28 over 7 reduces 4. Right. So let's actually use the calculator, and you could have done this for the other one as well to find the corner points. So let's pretend hit the y equals, and when we solve for y, so don't worry about the fact that, sorry, there we, oops, all right. -8. All right, and you can graph that and see what it looks like. Now we're only dealing with the first quadrant, so it's going to be right here. I'm not going to adjust the window. I just need a table of values. So second table, and I need where x is 0 and y is 0. All right. So I have 0, -8, and that's not going to work because we don't have negatives. And what's the other one? No, we don't have negative. Y's are going to be positive. There we go. And 8, 0. We also had 0, -8, but the problem is that would be down here somewhere, and we're restricted to this first quadrant. Okay, so that one's not going to work. And we'll get to that in a second. So we do need to find, let's see if there's a second point that's not. All right, 9, 1. Let's use 9, 1 just for graphing purposes. All right, so over 9, up 1, over 8, up 0, and let's look at the 1 on the right. So let's also put that in. Again, as long as we're just putting it in as an equation. Y equals, I'm going to hit clear. I generally don't like to put 2 equations in. I actually may have to do it here. All right, so 4 minus math 2 over 7. Arrow to the right, put in the X. Oops. And then hit graph. All right, so you see it's going to come through here in that fashion. Let's hit second table. Let's see. Everything has to be positive. So we have a 0, 4. And let's see if we can find where Y is 0. Up and 14, 0. So 0, 4, and 14, 0. Over 0, up 4, 14 up 0. Not very pretty. All right, so we do have 4 corner points. It's just shaped a little odd. Let's do purple. Corner point here, 2, 3, and 4. So we have a corner point at 0, 4. We have one down here at 0, 0. One at 8, 0. And then we need to find this one right here where the 2 equations cross. We can do this by, we can actually graph them both at the same time. Let's go ahead and do that. So Y equals, let's put that other one in. That was the first one we did. It was X minus 8. All right. All right, so you can hit second, trace, and you want to find where they intersect. This is actually easy function to use. So second, trace. All right, you get to intersect, you hit enter. It says first curve, you don't move anything, you hit enter. It says second curve, you don't move anything, you hit enter. It says guess, you hit enter. So that is where they cross at 9.3 repeating and 1.3 repeating. I will show you how to convert that to a fraction. So it's in second mode, it gets us out of there. So on the main screen, I'm going to do 9.3. I'm going to take about 2/3 of the way across the screen. Hit the math button. It's on fraction, so you hit enter. So you're telling it to take that number, convert it to a fraction. So hit enter again. And that's going to give you 28 over 3. The y coordinate was 1.3 repeating. So hit math. It's on fraction. You hit enter. So that is the other corner point. It's where the 2 lines intersect. So your homework is going to be similar. I do just take these questions from the view of the example. Okay. So let's look at the shading. Again, X is greater than 0, Y is greater than 0. That's everything here in the first quadrant. All right, so Y is greater than the line here. Okay, so this was the first line, this one right here that we're dealing with. Greater than is going to be above it. Let me see real quick. Make sure I got the right line. Over 8, up 0. And greater than is going to be above it to the left. Oops. I have no idea what happened there. All right, and then the last one, y is less than. So this last line we drew, it's going to be less than, which is going to be below it. Let me get a different color so it's a little more distinct. So the area where all of them overlap is right in here. So this is where the shading is. So that is where all four of those inequalities overlap. We have our corner points. Okay. Got a little shading in there. I shouldn't have. All right, so now we're going to get back. This one, they're asking us to maximize z equals 2x plus y. Oh, it's the same one. So that we need to find the maximum value using the corner points. So let's start by plugging those in. So this is the largest value. So the max value of z is 20 at the corner point. That was the last one that we used. 28 thirds, 4 thirds. All right, we have 2 more to go. Again, you may want to stop and work that problem on your homework and then come back and finish this. All right, we need to find the minimum and maximum value, if possible, for the following set of constraints. So we're going to have 3 that we're going to have to graph. So if we're only graphing 3 lines, I feel like we're going to have a triangle. Okay. So let's start with the first one. Let's move X. And I'm doing this so I can use the calculator to graph these. All right, so the next one, let's let it be blue so it's easier to keep track of. And then you can put minus 5x plus 18. That order is irrelevant. And let's do this last one in green. Subtract x. Then I'm going to divide each one by 5. Okay. So we have the equations. You have to stay very organized on this problem. Let's get to our calculator. Little y equals, clear, enter, clear, enter. All right. So let's get the first equation, negative x plus 10 graph. If you want to adjust your window, if you hit window, X min is 0, X max is 20. Don't worry about the scale. Y min is 0, Y max is 20. All right, so this is the first one we're graphing. So let's hit second table. We need 2 points to graph this. Let's see if I can find any zeros. I have 10, 0, and 0, 10. That's interesting. All right, so that's the red. We have 10, 0, and 0, 10. So I'm going to go ahead and graph that. Sorry about that. Thought that was on ignore. All right, y equals, let's clear that out. And put the second equation in. Graph. All right, that one's kind of steep. Let's do second table. Let's see if I can find the zeros. All right, if we can't find the zeros, it's not. We have 0, 18. I don't have any negative numbers. So let's do 2, 8, and 0, 18. That one's my blue one. Over 0, up 8. 5, 6, 7, 8. And then over 2, up 18, which is going to be 15, 16, 17. It's 0, 18, and 2, 8. I got those reversed. Try this again. 0, 18, 15, 16, and over 2, up 8. That's going to be pretty steep right there. All right, and then our green one, let's put that in. That was 18 over 5. Minus 1 over 5x. Make sure you arrow to the right before you put the x in. Hit graph, so you have an idea. It's kind of sneaking in there at the bottom. Second table. Let's see if we can find both of the zeros. I've already worked these. I know you can't. So we can do 3, 3, and 8, 2. Those are good ones. Right, over 3, up 3. And then over 8, up 2. All right, so this one only has 3 corner points. When we do the shading, we have y is less than on the red. And let me just get a lighter color. So less than is everything below. And then on the blue, it's y is greater than. So the blue greater than would be to the right. And then finally the green Let's look up here. Was y is greater than, so on the green we want above the line. Let's pick another color. Okay. So the area where all three of them overlap is right here. Shading. So we have a little triangle. Get all these out of the way. Just didn't mean to erase that line. Let me get the green line back in there. 2, and then over 3, up 3. All right. So we have 3 corner points. Okay, and I'm going to bring the green points down here just so I can look at them. All right. I don't see any overlap of the points. So we do need to find where they intersect. Okay. So I use the different colors. You don't necessarily have to have the colors. I would label them with colors. So we need to find where the red and the blue overlap. We need to find where the red and the green overlap. And then where the blue and the green overlap. Okay, so we're finding 3 ordered pairs. Okay. Where the red and the blue meet is right here. That's 1 corner point. Where the red and the green meet is right here. That's another corner point. And then where the blue and the green meet is the 3rd corner point. Okay, so I'm going to use that. Oops, at the wrong tab. All right, let's go to y equals. Let's clear that out. Let's see, I wanted red and the blue first. So negative x plus 10. And then 18 minus 5x. We hit graph. And we just need that point right there where they intersect. So second, trace, intersect. It says first curve, you hit enter. Second curve, you hit enter. Again, we're not moving that cursor. And it says guess, you hit enter. So that corner point is at 2, 8. The next one we're going to do is the red and the green. Okay, so the red is that first one I have in there. The green is going to be the last one I did. So let's clear that out. This one had all the fractions in it. All right, so that's that bottom right corner. So second, trace, intersect. First curve, hit enter. It'll say second curve, hit enter. It'll say guess, hit enter. So that point is at 8, 2. Okay. And then finally, we were going to do the blue and the green. Let's hit y equals. The green's the second one, so I'm just going to clear out the first one. Then we're going to do 18 minus 5x. Hit graph. So that's that bottom left corner. Second, trace, intersect. It'll say first curve, you just hit enter. Don't move anything. Say second curve, hit enter. Guess, hit enter. It's at 3, 3. And we're not getting any duplicate. So if you were to accidentally do 2 the same again, you would get a duplicate, which we don't want. Okay, you would get the same point. All right, so this one we need to minimize and maximize. Z equals 8x plus 6y. So these are our corner points. And we're going to plug each one of these into Z. I've already worked this stuff out. I'm not doing this in my head. All right. So this is the minimum value. And this is the max value. And that is at 8.2. And this one is at the minimum values at the minimum value is 42 and it's at 3.3. All right, and we have one more for this section. I know it's a long section. All right. Same thing here. We have 4 sets of constraints. We know how to graph y is greater than 0 and x is greater than 0. So that's just the x-axis and the y-axis. So let's graph those. Let's look at the other two we need to graph. All right, let's move the x. Divide everybody by 2. X over 2 is the same as 1/2 x. I mean, you could put the x over the 2. It's kind of irrelevant. It's the same thing. Let's move this 8x. All right, so again, we're going to use the calculator. And if we can find the x and y intercepts where x and y are 0, that's great. If not, the world's not coming to an end. So like clear out everything I have in here. I just hit clear and then enter. Let's put this first one in. That's 8. You can see what it's going to look like. All right, so if we look at this, actually, let's go back to the graph. I'm only going to see the the y-intercept. So I'm just going to have to pick a second point. All right, so I have 0, 8. And let's pick 2, 9. Okay. Over 0, up 8. Over 2, up 9. And then let's do the second one. Clear. Let's look at this one, negative 8x plus 8. Let's graph. All right, I do have the x and y intercepts. So we should have a 0 on the x and a 0 on the y. Oh, and look there, right there. We have 0, 8, and then 1, 0. Those are our 2 points. So this one's repeated, and then over 1, up 0. All right, so let's look at the shading on this one. We have x is greater than 0 and y is equal to 0. So that's just everything right here. And let's look at this one. So this one here, y is less than. That was the one on the top right, that short piece. Less than is going to be below the line. Okay. Then let's do light blue. This is y is greater than. That was the last line we did. Okay, so you can see where the three are overlapping. Let me shade that area. It's everything here. It's actually going to go on. That's big area. Okay. So let's look at our corner points. How many corner points do we have? We only have 2. We have this one here and this one there. This keeps going on and on. Okay, so we only have 2 corner points. We have one at 1, 0 and 0, 8. Let's see what they're asking us to do. They want us to find the min and the max values. Okay. Z equals 10x plus 2y. All right, so let's plug these in. All right. So this is our min value. And that is at the point 1, 0. Okay. So that's the smallest value. We don't have a max value here because this keeps going on and on to infinity. So we can't put a number on that. We do have an absolute lowest point. There are points that are higher than this that are up in here. So we don't have a max value. And that is the end of section 7.2.